The Rock Whisperer. Do you hear the earth talking to you? Welcome to your video notes. This is Unit 2, which we're going to be learning about mapping and latitude and longitude. So the first thing we need to talk about is going back to the age of Christopher Columbus and before that, and they used Polaris, which is also known as the North Star, in order to find out their latitude on the Earth. When you look at the picture in this diagram, you can see that if we follow the Big Dipper, which is a pretty easy constellation to follow in the sky and find in the sky, that if you find the end of the cup and follow that pretty much straight out, you'll find the end, the handle of the Little Dipper. That star is the North Star, or Polaris. So 3 facts that you need to know about Polaris. 1, the altitude of Polaris from your eye level up, that angle that you create is the same as your latitude. So we'd like to say that the altitude of Polaris is equal to your latitude. Remind me at some point, I can play a little rap song for you about that. Polaris is also a fixed point in the sky above the North Star. Polaris, during the night, all of the other stars and objects in the sky will appear to move. Polaris will appear to be a fixed star. So sometimes you see these cool pictures of the stars and they make these kind of trails and it looks like these streaks across the sky with one dot in the center. That dot would be Polaris. And the other fact that you need to know about Polaris, it's called the North Star. So therefore, in the southern hemisphere, you would not see Polaris in the sky. When we talk about the shape of the Earth, we need to realize that while we say the Earth is a perfect circle or a sphere, it's not quite perfect. When we take mathematical measurements of the diameter around the equator compared to the diameter going around the poles, the equatorial diameter is slightly larger than the polar diameter. Not by a lot. Actually, you'd be surprised on how close it actually is when you look at these numbers. But because of that, the Earth is called an oblate spheroid, which is the scientific term that means we're a little bit squished on the top and a little bit fatter around the middle. And that's the term that you'll see on test questions. The Earth is an oblate spheroid. When you look at pictures of the Earth, it looks like a circle. But we need to know mathematically that it does not come out to be like that. What you also need to do is at this point or at the end of this video is to go watch one of the other videos in the Unit 2 section by Carl Sagan, and it's on Eratosthenes, who was a famous scientist, librarian in ancient times, who did a really interesting calculation that was surprisingly accurate for not having a true standard of measurement for things, and calculated the circumference of the Earth. So as we have already kind of said, back in Columbus days, he would use something called a sextant in order to measure the altitude of stars in the sky. And if he knew the North Star, he would know his latitude, and therefore he could kind of try to sail across the ocean going from Spain and Portugal to the New World and stay at a fairly constant latitude, or know if he was moving too far north or too far south. So they were using Polaris again as that thing. So that would be what they would be using during the nighttime hours in order to do that, and then they have to recheck the following night, because you could follow east and west by doing the sun during the day, but only at night would you know your true latitude. So we know that the Earth is an oblate spheroid for 3 reasons. We have sent satellites up into space. We have also sent people into space. And when we look back at the Earth, we can see that the Earth is round in nature. It looks like a sphere. When we have an eclipse, we see the shadow of the Earth on the moon. And that is called a lunar eclipse, because the moon is being eclipsed during a full moon. And when that happens, we can see the edge of the Earth, which is curved, that tells us that the Earth is round. And the last thing that how we can tell is that the mast of a ship, so when a ship is going over the horizon and moving away from us, the mast is the last thing to disappear, or it's the first thing to appear if it's coming towards us. So if we look back at Columbus's day when people thought the earth was flat and people were disappearing, the whole ship just didn't drop off. It would gradually disappear, which leads you to believe that the earth is a curve shape. Well, that's it for this particular section, 2-1. Stay tuned for 2-2. Don't forget to listen to the earth. You just may hit